Okay, welcome to another episode of Trail Codes Workshop. This is a project I started not too long ago. I didn't film the building of it, but basically it's a Nixie tube driver. So I got these Nixie tubes and I have some more ordered. I wish these were the type that have the decimal point. I've been having a hard time finding ones that have a decimal point. I also probably should have gotten the sockets for them, but what I did instead was solder these pin headers onto the pins of the Nixie tube. I prototyped it first on a breadboard and I learned a couple of things. For example, these are the Russian version of a common 74 series logic circuit. I believe it's the 74141. And the difference on these is that they have high voltage transistors on the end. I've also found that the pins on these chips, they're once they get bent, they can break. So what I did is I put these other headers on here so that I can pull these in and out of here when testing to make sure I hooked something up correctly or not. Also on the board here, you can see that I have some of this thinner hookup wire, which I like a lot more. And I got this in the mail halfway in between wiring this up. Although it's probably a good idea that I use these thicker wires for the high voltage side of things. Once again, it's controlled with an Arduino, and these pin headers here provide access to power and the I2C bus. Once again, in hindsight, I wish I had a reset pin on these things here. These Nixie tubes have a common anode pin. I believe that's right, the positive side. That's denoted by the white inside the Nixie tube there. I really like how these things look. I have a old 1940s South Bend lathe, and I want to make like a steampunk looking digital readout and or RPM reader for it. So in the future I'd like to get these and bend brass pipes which will contain the wires and try and give the illusion of a different path in human history where electricity isn't the main driving force of technology. But down here, and these are mounted upside down so the electrons are falling out, but these are shift registers, so the 74595, and I'm using 3 of them, so there are 4 extra bits left over. And one thing I've thought about doing is putting some LEDs underneath here. Might add a cool effect to it. But when playing around with this on the breadboard, one thing I noticed that was interesting was I initially hooked the digital out pins of this Arduino to these Nixie tube driver chips, and it wasn't working, and I couldn't quite figure out why. And I believe these ones want, if you have a 0, it has to be tied directly to ground. It can't be floating. And I believe I tried pull-up resistors with dip switches, like this, for example, and that still didn't work. So it wants a good solid connection to ground for denoting a 0 on the input. Basically, these are binary coded decimal to the individual pins here. This here is a high voltage display or high voltage driver, so it's adjustable here on uh, how much voltage you want to give to it. It's a very simple design. It's made in the USA. You can find these on eBay. I also got this version here, which after reading the data sheet on it, has some protection in it, something with current. And I was able to get it to work a couple of times, but it just stopped working. I have not had much luck with it. I don't know what I did. Um, I guess I should read the data sheet in more detail and try and get it to working again. But the quality is really nice. I like it. So it looks like top one is positive and the lower one is negative. Okay, let's see here. I think I may have the clock and data pins for the I2C bus reversed on this one. And also with the wiring, like this chip here, I didn't wire it exactly the same as the others. But that's okay, I took care of it in the code. The way I see it is changing code is a lot easier than changing wires. Turn on the bench top power supply and give it some power. Well, it's drawing power, but I'm not seeing anything there. Oh, wait. Well, let me figure out why this is not working. Well, it would help if I put the high voltage power supply in on it. You can also see that these digits here need to be swapped around. That's easily done in the code. And it's not able to really display negative numbers. Let me turn the light down. But yeah, the rotary encoder is updating this display. Really like how it looks. Well, it looks like I was not recording that, but I got this dip switch in here. Running out of these 4-bit ones. I'm going to have to get some more. But this will allow me to assign an ID to it. So the Nixie tube display project needed a base. So I think this is fur. I'm not sure what it is. But basically I used the milling machine to cut this hollow spot in here. And then I took another piece, did the same thing, but cut a hole for the display. And then here's some space here for the high voltage power supply to fit. And then I drilled some holes for wood screws and countersinked it. And cut this little slot in here for the wires to go through. And I used the router to put the curves. Use motor oil to, so it smells kind of funny. I need to get some stain, but I like how there's this knot in here. I think that really adds character to this piece. Probably should have made this slot here a little bit bigger. Okay, so that was the I2C bus. Then we put the power in for the high voltage line. And need to make some spacers to offset this up a little bit, and then get some small wood screws to secure the board in there. There it is. Pretty happy with this. Wonder what I should put here.